Hello everybody, today I will talk about how can we communicate the gyroscope with Arduino and how can we take the readings from this connection. First of all, I want to say that we will deal today with this gyroscope and accelerometer and magnometer electronic card, and we can see the details of this electronic card as we can see here in this web page. You can see the details. It contains the three integrated circuits. One of them is responsible of taking the gyro readings, the other one is accelerometer, and the third one is a compass. If you want to see the datasheet for the integrated circuit, we should click these items and we can see all the details in these integrated circuits. We can see here from when we compare this electronic card with a coin, we can see that how much is it small. We have two versions. We will use version 3, this model, and we can see the connection of it here. The VDD represents 3.3 volt. The ground should be connected to ground, and we have these two outputs, and these are outputs deals with the Arduino based on protocol I2C. Of course, the connection with the Arduino here is an operational program, but we will not talk about it today. And these are the specifications for the electronic card and how is the current console, how much current for supplying it, and how are the output for the gyro, accelerometer, and magnometer. These are the important details. Here we can see that we have three directions for the axis. One of them represents the x direction, the other one represents the y direction, the third one represents the z direction. This drawing means that the z direction is coming from the screen towards us. So this is the x-axis, this is the y-axis, and this is the z-axis coming from the laptop to us. Here we can see how can we connect this this electronic card. This is not the same electronic card, but the connection is the same. Here we can see for the Arduino Uno we have two connections for I2C in analog in 4 and 5. It should be connected in this points SCL SDA. Then we can connect the ground and 3.3 volt for the VDD and the ground in this electronic card. It is very important to say that today I will talk about the gyroscope, and in the gyroscope what we can get for readings. First of all, we have an x-axis, y-axis, and z-axis. The gyroscope will provide us with the angular velocity towards the x-axis, angular velocity towards the y-axis, angular velocity for the z-axis. The reading of gyroscope will give us these items, angular velocity. And when I return to the code for my program, and you can see here I connected this Arduino Uno. As you can see here is the 3.3 volt. This the black wire represents ground, and these two wires represent the I2C connections. Here in the Arduino card we can see that these wires the yellow and green, will go to the uh, analog input 4 and 5, and we can see here that this is the 3.3 and this is the ground connections. Now I will explain the code for you. How can we take the gyro readings? First of all, I want to say and include this library for the I2C communication. These libraries are for gyroscope and accelerometer. Then we can define our variables. After that, we will make a setup. In our setup, we can see that we begin the serial communication, we begin the I2C communication, initialize the gyro, initialize the compass, and so on. Here we can see that the compass would read the data coming from the compass. Then we will read the data coming from the gyro. Here we want to calculate the time for applying this command of reading, starting of reading and another start for another reading. We should calculate the time, and I'll tell you how we can use it later. I will not talk about accelerometer today. I will go and talk about the gyroscope. In the gyroscope, we have the following readings. First of all, we have gyro dot g dot x. These value represent the angular velocity towards the x-axis. This represents the angular velocity towards y-axis. Here represents the angular velocity for the z-axis. We should multiply here with these 8.76 value multiplied by 1000, and using multiplying by this value to change to convert the reading to round per second, and we will make it for the 3 axes. Here we have these variables. After that we should calculate the angle. Here we calculate the angular velocity. If we want to calculate the angle depending on the angular velocity, we should multiply the angular velocity in round per second with the delta time, elevation time, which is the time for one sequence of reading the gyro. Multiplying the velocity with it by the changing of time will give us the angular distance, which means that the angle towards the x-axis, the angle towards the y-axis, and the angle towards the z-axis. After that, we will add the previous angle, because this is delta theta, and this is the previous theta, to get the overall theta, the whole angle towards the axis, as I explained before. After that, we will print the values here. And that's all. Here I will apply my program for the Arduino, and here I can see that is uploading. Now you can see the uploading is done. Now I will open the serial monitor, and I will try to see the readings. Here you can see that this value represents the angle towards the x-axis. You can see if I rotate in this direction, it will be minus. If I rotate in the opposite direction, it will give me the angle in the counterclockwise or the clockwise. Here the